Hello everyone and welcome to another C++ tutorial video. In this video I wanted to talk about selection sort. And in the last video in this series of videos about sorting, we did bubble sort, so we created our project then, and we created a few functions to help us out. So let's open up that project that we created last time. I will leave a link in the description for the bubble sort video if you want to see how we set things up, but I will also show you the functions here so you can go along with it from this video as well. So this is our bubble sort function that we had last time. And we had the random array, which takes in an array and gives us random numbers along the size of that array, and also the print array function to print it out to the console. And the last function that we're going to need now and implement in this video is a way for us to duplicate an array so that we can pass bubble sort one array for it to sort and pass selection sort the same array so that it can sort it as well, so we can compare the two algorithms. Let's get started by creating our duplicate array function. That will take a source array and a destination array and a size of these arrays. We'll create a for loop and just loop through the source and copy it into the destination. I++, and destination at I is going to be equal to source at I. And that's it. So all this does is it loops through from 0 to size -1 and copy whatever's in there from the source into the destination. And we'll create a couple of new arrays. So we'll create an array called bubble, and we'll create an array called selection as well. There we go. So we're randomizing nums here, and we just want to duplicate nums into bubble and selection. So we'll call our new function here. So we'll say duplicate array. Our source will be nums into bubble, and the size will be array size. And we'll do the same for our selection array. So nums, selection, and array size. Okay, so let's print out these arrays. Of course, we also need to set our srand value. So srand will take time, and that will be just the time, and that's 0. There we go. Just keep in mind you need to include time.h to do that, and that would be it. So let's print out both our arrays to see what they look like. So so we want to pass in bubble first, and the size will be array size, and we'll do the same for selection. Okay, now let's run it and see what we get. And as you can see, two arrays that have the exact same values in them. Both of them are size 10. Okay, now we can get started on our selection sort function. So we'll say void selection sort. Of course, it will take an array and a size, just like bubble sort. And now that we have all that, all that's left to do is try to explain how this sorting algorithm works. You can implement it in multiple different ways, but the way I like to do it is if you have an array of, let's say, 3, 1, 5, and let's say 2. I like to start all the way from the beginning. And once I start from here, I want to search from here all the way to where I am -1. So our indices would be 0, 1, 2, and 3. So our max index would be equal to 3 at first, because we're assuming that whatever we start at is the maximum value at that index. So we'll start at our max at 3, or wherever our I is, and search from 0 to I minus 1, which is 0 to 2. So we'll say, okay, so we have 3 here. Of course, 3 is more than 2, so our max index becomes 0, and then we keep going. 3 is more than 1, so we don't need to do anything. And then 2, at 2 we have a 5, and 5 is more than 3. So our new max index would actually be 2. And all the way at the end of doing that, we end up with our I at 3, our max index at 2, so we end up swapping these two. Once we do that, we will have a 3, 1, 2, and 5, and then we repeat the process on the next index. You will probably notice that by doing it this way, our last index, so the last index that we were at, we are sure that this is the highest out of the remaining indices. So let's get started and create this function. As you can see, we're starting all the way at the end, so we can say for int I equals size minus 1, I is more than 0, and I minus minus. So we're starting all the way at the end, and we're going back by 1 every time. And our second loop would be for nj equals 0, j is less than I, and j plus plus, because j starts from 0 all the way to wherever I is minus 1. And we'll say that if a at the max index, oh, we need a max index, int max index. And of course, as we said earlier, our max index always starts at where our I is. If we're here, then our max index is 3. So if a at max index is less than a at j, then we'll say that our max index is equal to j. Just like we did here. It became 3, and then 0, and then 2, and this was our maximum index. So we'll do that, and at the end of the I, we'll do our swap. So we'll say temp is going to be equal to a at the max index. A at the max index is going to be equal to a at I. And then finally, a at I is going to be equal to temp, just to swap our values. And this should be it. Oh, we need int j here. And this should be it for our selection sort function. Now we can go down here and do our sorting. So we'll say bubble sort our bubble array. And selection sort our selection array. There we go. So let's run that and see how it goes. Okay, and as you can see, we have two sorted arrays. One of them using bubble sort, and the other one is using selection sort. In bubble sort, it tells us the amount of comparisons and swaps that it made. So let's do the same for selection sort. As you can see in bubble sort, we are doing an edge case check for the size. So let's do the same for selection as well. We'll say that if the size is less than or equal to 1, just return, because if the size is 0, then there's nothing to sort. If the size is 1, then our array is already sorted and there's nothing that we need to do. Next up, we will declare a few variables, which will be comps, which will start at 0, and also swaps, which will start at 0 as well. So comparisons, where are we doing comparisons? Right here, we are doing some. So we'll say that the comparisons plus plus here, and we are doing our swaps right here. So we'll say swaps plus plus right there. Finally, let's output what we just did, which will be std cout selection sort, comps will be our comps, and the swaps will be our swaps. And finally std end line, and this should be it. We can try to run it now, and as you can see, 81 comparisons for bubble sort compared to 45 for selection sort, 32 swaps for bubble sort compared to 9 swaps for selection sort. And you'll notice that selection sort will always have size minus 1 swaps, because we only do a swap at the end of the outer for loop, so at the end of this one. And this one only goes once from I to the size minus 1. This is why we end up with size minus 1 swaps. If we try to run it again with different numbers, as you can see, 54, 45, 16, and 9. Our swaps will always be constant, but our comparisons will also be constant for selection sort. They will not be the same for bubble sort. If we try to run it again, as you can see, it's always the same for selection sort, but it differs in bubble sort, both swaps and comparisons. So selection sort is a much better algorithm if you want a specific amount of comparisons and a specific amount of swaps that you need to have. Of course, there are other searching algorithms that are more efficient than selection sort, but this is an upgrade from what we had last time. Maybe we can do something here to just show our comparisons and arrays together. So we'll just say sort and print, and then sort and print. That way, there we go, much better. That way we will have our comparisons and our swaps right on top of the actual array. But I really hope that this video helped. Thank you very much for watching. If you have any questions, suggestions, feedback, or comments, please leave them below. Other than that, thank you very much for watching, and I will see you in the next video.